Welcome all for this chapter Simple Stresses and Strains. Earlier in 3 video lectures we have started this chapter and we have come up to the numerical part. Myself Dr. A. J. Kulkarni welcome all you for this Simple Stresses and Strains. So earlier we are familiar with the deformation, internal resistive forces, external forces, stress, strain, shear stresses, shear strains, Hooke's law, elastic constants, Poisson's ratio, and some of the numericals also we have seen. We were discussing this last numerical, and while discussing that numerical we have seen the concept of factor of safety. So once more we will clear the concept of this factor of safety. So the particular ratio of ultimate stress to working stress or permissible stress. In general, whenever any material, any component is working, then that particular component or machine element is not raised to increase the stress up to its ultimate stress or yield stress. The terminology of ultimate stress and yield stress that is used in case of any brittle or ductile material, that part now we are going to study, because now in this lecture we have to cover the stress strain curve, and there we will clear the concept of ultimate stress and yield stress. The yield stress is the concept which is used always in the ductile material. Ultimate stress is the concept which is used always in brittle material. Is it okay? So working stress or permissible stress or safe stress. So maybe these are the synonyms to each other. So this particular stress is allowed for the material. This is the working stress, or this is the safe stress. So these stresses are considered to be our desirable stress. So that is the stress considered to be the stress for which the particular material should work. It should not extend beyond that. That is considered to be working stress, permissible stress, desirable stress, or safe stress. Is it okay? And ultimate stress is the maximum stress. So it is advised that the particular material inside which the stress should increase up to working stress or permissible stress, it should not extend beyond that, and based on that the concept of factor of safety is given. So factor of safety is maximum stress to working stress. Maximum stress in case of ductile material is yield stress, in case of brittle material is ultimate stress. So in this example that ultimate stress is provided. Secondly, we were discussing about this calculation. So stress is equal to force upon area. The value of stress is 120 is equal to the value of the force load that is substituted here, and this calculation is very important, because this calculation I will suggest you that you should use the steps, and by step you go for this calculation, because here the cross multiplication will be required, 120 into this particular part, and here this numerator part that we will have to keep here. So simplified here, 40,000 minus d square is brought in left side. So this is in denominator, will come to the numerator when it is transferred to the left side. This 120 that is transferred to the denominator. Is it okay? Though this type of calculation you are observing as a simple type of calculation, still I will suggest you that don't consider this as a simple calculation. You do that calculation on by your own and solve this example, because there may be the chances that if you not proper take the steps by using the calculator, then this may be wrong, your answer may be wrong. Though your example is correct up to this step, and here you are making some kind of mistake, then also your diameter will be wrong. So inner diameter calculation, for that purpose this simplification is required. So here you will simplify this, and later on this minus d square will, if you brought in right side, this will become plus, and this calculated part when you subtract from this 40,000, then this will become, so this calculated part is 20,159.4. So that is transferred to the left side, this will become negative, minus d square become positive. So d square is equal to 40,000 minus 20,159.6. It becomes 19,840.4, and inner diameter you are getting as 140.85 mm. So that is the solution to this numerical. So you should take the care while calculating the things. Then let us come to the stress strain curve of the ductile material. So let us see here. Basically, we are using UTM machine, universal testing machine, while identifying the stress strain behavior of any bar, any material component. So these are two jaws, one is fixed jaw, another is moving jaw, and step by step force is applied to the component which is present here. So we may consider this as a specimen. So okay, the specimen sizes are based on the STM standard or British standard or Indian standard, Bureau of Indian Standard. By that way, the particular specimen size is decided, and that is fixed in between upper jaw and lower jaw. Okay, once the force is started to apply, then one jaw starts to move, another jaw is fixed, and then due to application of force, so here you will get the values of the applied forces and the stress and strain produced inside the material. So initially, as this force starts to increase, as force increases, my area remaining constant, cross-sectional area remaining constant, and force increases, stress starts to increase. And already in Hooke's law we have seen that stress is directly proportional to strain, and this happens up to the elastic limit. Okay, so here if we observe the nature of the graph, then stress increases, strain also increases. So this particular line is showing here stress increases, strain also increases. So stress is directly proportional to strain. So this linear nature, linear behavior of this line indicates that stress is directly proportional to strain. So this point is considered to be proportional limit. This point A is considered to be proportional limit. Here this point is B point. We are considering as elastic limit. Is it okay? Proportional limit and elastic limit. So A and B points. So understand the difference between A and B. A we are considering as proportional limit. B we are considering as elastic limit. So this particular stress is directly proportional to strain, and this happens up to the elastic limit. So elastic limit we may consider that the material remains elastic in nature. So it will regain its original size and shape. Up to this point, if deformation happens, then material regain its original size and shape. Is it okay? Then coming to this next point, this is upper yield point, and here it is lower yield point. So the two kind of material we are always considering, ductile material and brittle material. If we take example of mild steel, then mild steel is the ductile material. But if we take the example of cast iron is the brittle material. So if we try to plot the graph of stress and strain in case of brittle material, then that will be not like this. But if we try to plot the stress and strain graph for the mild steel, then that will be like this. Is it okay? So this particular graph of stress and strain, or the particular curve of stress and strain, is for ductile material. So see, this is proportional limit, elastic limit, upper yield point and lower yield point. In case of ductile material, yield stress or yield point stress is considered to be maximum stress. So recently in previous example we have seen the concept of factor of safety, and while defining the factor of safety we have considered as the ratio of maximum stress to the working stress. And maximum stress in this case is considered to be yield stress. Is it okay? So by observing this graph, here we can see that this is the particular point which is considered to be the point where maximum stress occurs in case of ductile material, and this particular point we are considering as the upper yield point. So this point is considered to be lower yield point. So we should understand the difference between these two points, upper and lower yield point. So this particular point, which is upper yield point, will be considered as the point where maximum stress occurs in case of allowable stress or working stress. We may consider as yield point stress. Is it okay? So if that particular specimen is again loaded, means again force is applied, then this graph again increases. So with reference to this point, which is lower yield point, again Stress increases, strain also increases. Is it okay? Stress and strain. Here you can see this line. Stress increases, strain also increases. Then this point comes where the maximum value of stress occurs, and beyond that again this starts to decrease here. Is it okay? So this is increasing, stress is increasing, strain also increasing, and this particular point is the highest point. If we identify the corresponding stress of this point, this will be considered as ultimate stress. So that ultimate stress may be the maximum stress in case of ductile material, but from design point of view, yield stress is considered to be a maximum stress in case of ductile material. Is it okay? So this point E here you can see this is the corresponding stress of this particular point we are considering as ultimate stress, or this point we may consider ultimate strength. So this is yield strength, this is ultimate strength, and corresponding values of stresses will be considered as yield stress and ultimate stress. Is it okay? And finally this particular point we are considering this as breaking stress or breaking point. So one by one if we observe this here, then this is proportional limit, elastic limit, upper yield point, lower yield point, ultimate tensile stress and breaking stress. Is it okay? So this stress strain curve in case of ductile material, for that these points are going to occur, and this case we have considered this is the example of mild steel. Is it okay? Similarly here you can see that on the particular specimen, if this is dog bone shape like this specimen, initially when it is loaded, when force is applied to it, then wherever the weaker section is present, there this neck formation happens, and at this breaking point these two separate pieces will be observed here. Here in this UTM machine, when the load is increased, then the two pieces will be formed, and this happens at this breaking point. So before that this kind of neck formation, here you will observe this section is considered to be neck formation. Is it okay? So yield stress, ultimate stress and breaking stress. Likewise here we can consider this position of the or shape of this particular specimen is like this. Is it okay? So here also you can see the points are marked here: proportional limit, then elastic limit, then yield point, and then ultimate strength. This is actual rupture strength and this is rupture strength. So try to understand the difference between that. If this particular graph doesn't comes in downward direction, but if it is extended, then that may be the actual rupture strength. But it doesn't happens at this point. This graph, whenever ultimate strength is achieved, later on this graph decreases in downward direction, and here though stress is not increasing, strain increases. Is it okay? This particular point is considered stress is not increases but strain increases, because here strain starts to increase but stress doesn't increase. Is it okay? Here, and later on if we will observe here, this particular point comes where the material breaks into two pieces, and this is the rupture strength. So there is difference between actual rupture strength and rupture strength. So we are going to see the numerical based on this particular part. Similarly, one more thing you can study here. This is in case of brittle material. If you observe, in case of ductile material, the stress and strain, this graph we have seen, but in case of brittle material, there are no intermediate points. So if you observe this stress strain curve, once this particular point is of this point also not observed, this is calculated point by with the help of proof stress method, but directly breakage of the breakage into two pieces happens, and that's why only ultimate stress is observed in case of brittle material. So stress is directly proportional to strain up to this point, and later on directly crack happens inside the material and failure of the particular material in two pieces will happen. This is the brittle material. We have taken example as a cast iron. So in case of cast iron, if you see, so here this kind of directly failure happens, and this is the ultimate stress. Is it okay? So that's why brittle material, we are considering the material as a brittle material, where when load is applied, so directly breakage happens and very small amount of strain is present. Thank you.